Hello grade 12s and welcome to this video in which we're going to be taking a look at hydrocarbons, what they are, and also how we can test to see whether certain hydrocarbons are saturated or unsaturated. We say that the hydrocarbons are organic compounds that consist of hydrogen and carbon only. So if you watched the previous video, the one that was the introduction to organic chemistry, you would already know that the hydrocarbons include the alkanes, the alkenes, and the alkynes, because these are the homologous series, the groups of organic compounds that only contain hydrogen atoms and carbon atoms. If we look at the haloalkanes, for example, they contain halogen atoms like fluorine, chlorine, bromine, and iodine, and they are therefore not considered hydrocarbons. If we look at the other compounds like the alcohols, the ketones, the aldehydes, they contain oxygen atoms, and they are therefore also not considered hydrocarbons. The hydrocarbons only include the alkanes, alkenes, and the alkynes. Now, there are two different types of hydrocarbons that we'll be studying this year. We get saturated hydrocarbons and unsaturated hydrocarbons. We say that saturated hydrocarbons are compounds in which there are no multiple bonds between carbon atoms in their hydrocarbon chains. Or we could define saturated hydrocarbons as compounds with only single bonds between carbon atoms in their hydrocarbon chains. Since the alkanes and alkenes and alkynes are the only hydrocarbons that we are studying this year, it means that the only saturated hydrocarbons that we're studying is the alkanes, because the alkanes contain only hydrogen and carbon, but also only contain single bonds. For example, here we have butane. And you can clearly see butane contains only carbon and hydrogen atoms, but between all of the carbon atoms and even the hydrogen atoms, there are only single bonds, and therefore this compound is a saturated hydrocarbon. On the other hand, we have what we call unsaturated hydrocarbons, and these can be defined as compounds in which there are multiple bonds between carbon atoms in their hydrocarbon chain. By multiple bonds, we are referring to double or triple bonds. So while the alkanes are considered saturated, which means they're in a sense full, there's no space for them to accept more atoms, the alkenes and alkynes are considered unsaturated because they contain double and or triple bonds. And therefore these double bonds can in a sense break apart, so that they can accept more atoms and become saturated. So for example, butene, it has a double bond on its second carbon, and therefore this alkene is considered unsaturated. Bute-2-ine contains a triple bond on its second carbon, and therefore since it contains a triple bond or multiple bond, it is considered an unsaturated hydrocarbon. Now, sometimes you may be given two samples of clear hydrocarbons, and you'll be asked to test for saturation. In other words, you'd be asked to test which one is saturated and which one is unsaturated. In order to do or perform this test, you can make use of bromine water or potassium permanganate. Bromine water has a brown color, while potassium permanganate is purple. If you take bromine water and add it to a clear saturated hydrocarbon like hexane, a reaction will not take place spontaneously, which means nothing is going to happen on its own unless you provide it with additional conditions like UV light or heat. But at room temperature, nothing's going to happen on its own, and therefore you're going to end up with a mixture. No reaction is going to take place, and the solution will therefore turn brown. But if you take bromine water and you mix it with an unsaturated hydrocarbon, like hexene, which is an alkene that contains a double bond, what is going to happen is that as you drop the bromine water, this brown solution, into the hexene, The unsaturated hydrocarbon will accept the bromine into its hydrocarbon chain. A reaction will take place to form a haloalkane, and therefore the solution will be clear. It will not be brown like in the case of the saturated hydrocarbon. It works the same with the potassium permanganate. If you take your potassium permanganate and add it to an alkane, which is saturated, the solution will turn purple because you just have a mixture of the alkane and the potassium permanganate. But if you add it to an unsaturated hydrocarbon, like an alkene, the solution will lose its color. It will no longer be purple. Now, to make better sense of this, I'd like to show you the following chemical reactions using these chemical equations. The top equation makes use of structural formulae, and the one below includes molecular formulae. So over here, we have what is referred to as ethene. It is an alkene and therefore an unsaturated hydrocarbon. We are reacting ethene with bromine water, which contains Br2. When you place the bromine water into the ethene, a spontaneous reaction takes place. One of the bonds in the double bond breaks. The bromine will also break apart, and therefore the one carbon will accept the one bromine and the other will accept the other bromine. Carbon is a special type of compound that is able, or special type of atom that is able to make a maximum of 4 bonds. And over here you can see that once the ethene accepts the bromine into its chain, all 4 bonds are used up, and therefore it becomes a saturated compound. Specifically, it becomes a haloalkane. Below, we have exactly the same reaction that we are showing with molecular formulae. And as you can clearly see, the molecular formulae do not show where the bonds are. They also don't show what types of bonds they are, whether they are single, double, or triple. They only show the types of atoms. By the way, this should be a 2, and this should be a 2 as well. So they only show the types of atoms and the number of each atom that is present in the different molecules. Now over here we have an example of a different compound. In this case it is ethane. This over here is an alkane. The same mistake was made in these molecular formulae. There should be a 2 by the carbon. So as you can see, ethane is a saturated hydrocarbon because each carbon has all of its bonds taken up, right? So there are no double bonds and no triple bonds. When you take your ethane and you mix it or put into it bromine, a spontaneous reaction does not take place. So a reaction will not take place on its own. And for a certain period of time, you're going to just have exactly the same mixture of bromine and ethane. And therefore your solution is going to be brown. This is because a saturated hydrocarbon has been mixed with bromine water. And below we have again the molecular formulae, which only show the number of each type of atom and of course the different types of atoms taking place in this reaction. So if you have some extra time available, I do suggest that you go onto the internet and go look for videos where they actually test for saturation so that you can see how the reaction takes place. Otherwise, we've reached the end of this video. In the next video, we're going to look at the rules that we follow in order to name and draw organic compounds.